Welcome to True Projects. In this video, we will explain the topic which is You Walk, We Authenticate, a lightweight seamless Python project based on Gait in wearable IoT systems. Introduction. Personal information such as health disorders and banking passwords can be stored in smart devices such as health monitoring sensors and watches and also eyewear. Passwords are used to unlock devices to prevent unauthorized access. However, today's people uses many devices making passwords tough to remember. Instead of passwords, accelerometer and gyroscope sensor data can be used to solve this problem. Without the use of passwords, these patterns can be utilized to authenticate users. For this project, lightweight seamless authentication framework based on Gait, which is LISAG, is proposed. Objective. The project's goal is to develop LISAG, a lightweight and seamless authentication framework based on unique Gait patterns acquired by accelerometer and gyroscope sensors in wearable IoT devices. The project uses machine learning techniques which are random forest, KNN and MLP to authenticate users without the usage of passwords by leveraging user-specific mobile data. Major goal is to improve user experience by providing a safe and convenient authentication technique that addresses password management issues in the context of various smart devices. These are the requirements for execution. First one is hardware requirements. In that, operating system of Windows, processor of 5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are needed. In software requirements, we need Python IDEL of 3.7 version. Algorithms used in the project are: first one is K nearest neighbor. KNN is employed to classify and authenticate users based on their gait patterns. It operates by calculating the distance between the input and the training dataset. KNN identifies the K nearest neighbors in the training dataset and classifies input based on the majority class among these neighbors. In the context of this project, KNN is used to determine if the current gait pattern matches any of the pre-registered users' pattern, enabling user authentication. Second one is random forest algorithm. The random forest algorithm is utilized to enhance the accuracy of the authentication. It operates by creating an ensemble of decision trees where each tree contributes to final classification decision. Random forest is capable of handling complex patterns and interactions in the data, making it suitable for capturing subtle differences in individual gait patterns. By leveraging the diversity and combination of multiple decision trees, random forests aim to improve the precision of authenticating users based on their unique movement signatures. Third one and last algorithm, which is multi-layer perceptron algorithm. MLP is a type of artificial neural network that is applied in this project for further enhancement using authentication accuracy. MLP consists of multi-layer perceptron interconnected nodes, and it is capable of learning complex nonlinear relationships within the data. In this context, MLP analyzes the intricate correlations with the gait pattern data and allowing it to distinguishing between users' unique movement styles. Although the presented results show lower accuracy for MLP, it demonstrates the exploration of different algorithms to determine the most suitable approach for authentication. Coming to methodology, we have designed these 7 modules for execution. First one is upload accelerometer and gyroscope sensor dataset. In this module, it involves uploading the dataset containing accelerometer and gyroscope sensor data that is collected from users' walking and sitting patterns. This dataset is the foundation of this project and contains the raw data needed to train and test the machine learning algorithm for the authentication. Next one is generating train and test model. In this module, we upload the dataset, and that dataset is divided into train and test length. Training set is used to teach the machine learning algorithms that patterns associated with each other's user gait and movement. Testing set is used to evaluate the accuracy and performance of the trained algorithms. Third one is run KNN algorithm. In this module, we train KNN algorithm on trained data, and this model is applied on test data. Similarly, we will run random forest algorithm and multi-layer perceptron algorithm. Sixth module is accuracy graph. This module involves plotting a graph that compares the authentication accuracy of the different algorithms, KNN random forest and MLP. Seventh module is authentication user using accelerometer and gyroscope sensor data. In this module, a new set of accelerometer and gyroscope sensor data is collected when a user attempts to access a smart device. The collected data is then fed into the trained machine learning models, which are KNN, random forest and MLP, to determine the user's gait pattern matches any pre-registered patterns. For execution of the project, first we need to open the code folder. This is the code folder of the project. This is the dataset folder, and this is the main dataset. This is the data. And these are the features of the data. And this is the dataset URL through which we can download the data. And this is the test data for which we will be predicting. And this is the Python main code file, and this is the run.bat file. Instead of executing the project in command line interface, we have created Windows batch file for execution. So we need to double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program, and this is created by using Tkinter library in the Python. So first, we need to click on the button Upload Accelerometer and Gyroscope Sensor Dataset to upload the data. So here I will select this data and click on Open. Here it is confirmed that the dataset is loaded, and the total number of features found in the dataset are 562. Now we need to click on the button Generate Train and Test Model to split the data into train and test length. Here, the total dataset length is 7352. After splitting them into train and test, in train we have 6616, in test we have 736. Now we need to click on the button Run KNN Algorithm. All the algorithms, first they will train on the train length, which is 6616, and then they will predict it on test length, which is 736. Now I will click on the button Run KNN Algorithm. Here KNN algorithm is performed, and here is the accuracy of the KNN algorithm. Now we need to click on the button Run Random Forest Algorithm to perform the Random Forest Algorithm. Here we can see that Random Forest Algorithm is performed, and here is the accuracy of that algorithm. Now we will click on the button Run Multi-Layer Perceptron Algorithm. Here we got the multi-layer perceptron algorithm accuracy. Now we will check the accuracy graph. Here on x-axis algorithm names are represented, and on y-axis we have the algorithm's accuracy scores. This is the KNN algorithm accuracy, this is random forest accuracy, and this is multi-layer perceptron accuracy. Among all the algorithms, multi-layer perceptron accuracy is very low. Now we will click on the button Authenticate user using accelerometer and gyroscope sensor data to predict the algorithms. So here I will select the test data and click on Open. Here, (562) double values are the user movement data, and in selected text we can see this value is authenticated and matched with user ID 1. So close this UI. Conclusion. This project we authenticate lightweight seamless authentication based on Gait in wearable IoT systems, provide a secure and user-friendly alternative to standard password-based authentication methods by employing different Gait patterns as a form of authentication. Project effectively illustrates the practicality of the proposed LISAG framework, which uses accelerometer and gyroscope data, as well as machine learning techniques, to authenticate people based on their distinct movement patterns. The project demonstrates the potential for improving user experience in wearable IoT systems by removing password management and complications while retaining high level of security via personalized and seamless authentication.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.